Trebuchets. They are the medieval equivalent of the atomic bomb. Their function was to take down entire castles. But how do trebuchets work? Well, they work about like this. Every trebuchet has 6 main components: the counterweight, the throwing arm, the base, the sling, the trigger, and the fulcrum around which the throwing arm rotates. The basic concept of a trebuchet is pretty simple, really. It's a first-class lever. A load is applied on one side of the fulcrum, and an opposite force is applied on the other. It operates on the same basic principle as a seesaw, just with a larger and more violent outcome. On a trebuchet, the counterweights are raised high above the ground. The weights have a lot of mass, and because of this, they store an enormous amount of potential energy. This potential energy turns into kinetic energy as the weights fall, creating a very large downward force on the counterweight side of the arm. The fulcrum takes this force and transfers it directly into an upward force on the throwing side of the arm. Because the throwing side of the arm is nearly 2.5 times the length of the counterweight side of the arm, the tip of the throwing arm moves twice as fast and twice as far as the weight. This is called mechanical advantage. The sling is one of the coolest parts of the trebuchet. It holds the projectile, but also has to release it at the top of its range. To do this, the sling utilizes centripetal force. This force holds the projectile in place using inertia. The rope is held on by a pin. The angle of this release pin decides what angle the sling releases at. The ideal angle for the sling release is 40 degrees. All of these things have to combine to make a trebuchet work, and I think we succeeded at that.